Hello everyone, my name is K. Reddy, working as a assistant professor in Tigal Krishna Engineering College. In this video, I will explain unidirectional pulse width modulation. In this video, I will apply unidirectional pulse width modulation, single phase two-level inverter. In my previous video, I will explain it clearly bipolar pulse width modulation. I designed a circuit in MATLAB simulation software. In this video, I will design unipolar pulse width modulation. In this unipolar pulse width modulation, now I will explain these waveforms. In this unipolar pulse width modulation, here two sine waves. This is first one, positive Vm. This is positive up to 0 to 180 degrees, 180 to 25. This is negative of cycle. Next here, this is second. This is minus Vm, 0 to pi. This is a negative. Next cycle, next pi to 2 pi. This is positive cycle. In this waveform, have two sinusoidal waves and one triangular wave, one repeating sequence. Okay, this Vg1 first generated from compared to Vm and Vcr. This like 10 sine wave greater than triangular wave. This Vg1 first generated. Next here when Vg3 when sine wave is greater than triangular wave, this Vg3 third pulse generated here. Vg1 and Vg3 are gate pulses. Next here VAN, VBN. VAN is a phase voltage, like phase voltage here. Next VBN also phase voltage. This is VAB is the line voltage. Line voltage means VAB is equal VAN minus VBN formula. Okay, these are the output waveforms. Unipolar pulse width modulation. Now I will design in this unipolar circuit in MATLAB simulation. First, I will click here Simulink. In Simulink, I will take commonly used block. I will take one scope and one relation operator. Next, I will go to sinks. In sinks, I will take one sine wave and one repeating sequence wave. Next, I will go to sinks. In sinks, I will take one scope. Next, I will go to in electrical. In Simscape, I will go to specialized technology. In specialized technology, fundamental box. In fundamental box, I will click here electrical sources. I will take one DC voltage source and elements. I will click here elements. I will take one RLC branch. Next, I will click here power electronics. I will take one IGBT switch. Next, in measurements, I will take one voltage measurement and I will take one current measurement. These are the main components for designing unipolar pulse width modulation circuit, inverter circuit. I will divide one by one. One side I will design controller circuit, second side I will design inverter circuit. Next I need from and go blocks. I will go to commonly used blocks and I will go to signal routing. I will take one from block and one glow block. Now I will start view connections. First, I will rotate this thyristor, this IGBT. I will right click this one, this symbol. In right click here showing rotate option. In rotate option, I will click here flip block left to right. Okay, I know need this E. E means thyristor port, thyristor elements first. I will take total 4 thyristors. I will take one DC voltage source. I will connect load. I will take only R load in the circuit. I will connect load here. Next, I will connect to C to C. Next, I will connect E to C. Next, I will connect E to this C. I will connect here one voltmeter across the resistor. Voltmeter positive connected to resistor one end. Next, voltmeter negative terminal connected to resistor second end. Next, I will connect this E to E. Next, voltmeter positive connected to here. Voltmeter voltage, supply voltage negative connected to here. Okay, this is total topology circuit. Now I will give connections from block. I will double click here. I will give name S1. I will give the switch S3. S3. I will give here switch S4. This I will give switch S2. Next, I will select all symbols. I will remove names, format. I will show block name. I will remove all. Next, I will connect here one. I will rotate the switch. This measurement, voltage measurement. I rotate it to right. This negative terminal connected to end here. I will rotate this here. Voltmeter is connected to here. I will apply here V0. V0. I will connect here from block. I will change the name here V0. V0 means the load output voltage. Now I will give connections here. Source side. I will connect first sinusoidal signal. I will give here greater than or equal. Next, I will take one more sine wave. I will take one more comparator wave. I will take two sine waves and one triangular wave in this for designing circuit. Next, I will connect from blocks. I will connect this one to this. Next, I will take one NOT gate. I will double click here logic gates. In logic gates, I will take one NOT gate. I will double click here. I will apply NOT. If NOT gate connected, I will connect here. I will change here names S1, upper switch S1, upper switch S1. This lower switch S3. Next, I will connect here. This switch I will give name S2. Next, I will take NOT gate. I will give here S4 name S4. Now all 4 pulses generated here. Now I will give here values. Here I will give here name MA. Here I will apply frequency 2 pi into 50. I will apply 2 pi into 50 edges. Here also I will give modulation index MA. Next frequency 2 pi into 50 edges frequency. Here I will give phase shift 180 degrees pi value. Now I will run. Now completed. Next I will go to this frequency value MA is equal 0.5. Next FCR 900 edges. Now I will give here repeating sequence value. First I will apply 0 and 1. 1 divided by 4 5 into FCR. Next 1 by FCR. So that is a switching frequency here. FCR is the frequency kilohertz. Next, I will give here sequence 1, 1, minus 1, 1, and now I will apply this one. Connections completed. Now I will take one power guide block. Will apply. I will add this one. Will change here this speed. I will delete this scope, extra scope. Now I will take one mux and demux. We will connect here this two input. Now I will give here output port. Now I will apply here MA is equal to 0.8, FCR is equal to 900, it's equal to 0.8, FCR is equal to 900. Now I will run this circuit. Now circuit is simulating. Now I will show output. Okay, I got output like this. This is starting from 0.908. Now I will change here parameter values. That time our input come from 0.11 value. I will remove this one. I will apply. Now I will run the circuit. Now I will show output. Okay, I got output like this. Okay, want clear observe. I will change here time 0.2. Now I will run the circuit. Okay, output I got output like this. AC here this is a 3-level inverter. One is positive 100, second one is 0, third one is negative 100. I got AC output. I got 8 AC output like this. Okay, here ABC. One is positive VDC, 0, negative VDC. Next, I will show here the sine and triangular pulse waveform. Okay, observe here in the circuit is this is sine wave, this is triangular wave, this is sine and triangular comparison. Next, I will show these two sines on triangular waveform. I will double click here. I will give 3 input ports. The third port connected to here sine wave. Now I will run the circuit. I will show waveform. Okay, here observe clearly in the circuit have 2 sine waves. Okay, 180 degrees phase shift each other and one triangular wave. Now I will show THD value. Go to the settings. In settings here, save data workspace. Here change structure with the time. I will change the name. This is V1. Now apply this one. I will run the circuit. I will go to Power Guide. In Power Guide, here tools, click here tools, in tools, FFT analysis. Okay. Now FFT analysis open. Now I will click here FFT one. I will click. This is the voltage, output voltage waveform. I will start with time 0.02. I will take one cycle, THD. I will change here frequency value 50 Hz. Now I will click here display. Okay. I got THD value 77.96. I will increase the number of cycles 3. Now I will click here. Okay. THD value is 77.96. So finally I got output, but THD is very high in unipolar pulse width modulation. Okay. Now I will save this output waveform with high resolution. Okay. I will double click this one. I will click here. Try to Simscape. Click here, try to Simscape. Window open like this. New window open like this. Here click here Power Guide file. In file here click print figure. In print figure here have edit option is there. Click here figure properties. In figure properties click here property editor. In property editor I will change here color. Now here also I will change color white. I will change this yellow color also. Will change red color. Next I will change borderline color. I will change font size here. I will apply font size 14. I will keep bold. Next, I will write here y-axis name. Y-axis is output voltage. Next, in x-axis, I will type here time in seconds. I will take only few cycles. That's why I will change here 0.01. 0.1. I will click here. Will change 0.05. Okay, I got output like this. I will save this waveform with IEEE format. Now I will save this JPG format. I will click here JPG. I will save this waveform in desktop. I will in unipolar. I will save name unipolar. I will save in desktop. And now I saved. Once I will check waveform. Okay, this is the output waveform. Okay, finally I got output waveform this like this unipolar pulse width model. Thank you for watching this video.